Hello, so welcome to this lecture video. So this is about two variable continuous distribution. So this is part B. Okay. So if we have two variables, then we have some conditional distribution, right? So we have some conditional probability, conditional expectation, those things. Okay. So for this problem, we want to calculate this probability under this condition. So this conditional probability. Okay. So for this problem, so we need to find the conditional distribution. Okay. So let's say here the range for x, y, x between 0 to 1. So y is between 0 to 1 minus x. So y equal 1 minus x. This is this line, x plus y equal 1. So okay, so this x plus y equal 1. Okay, so we know this the region is this triangle, right? Okay. Okay, so when x equal 1 over 3, x equal 1 over 3, so y is from 0 to this 2 over 3, right? Y is so under this condition, all y is just y is between 0 to here. So we want to find this probability x less than y. So x less than y. So let's say so here y equal x. So y larger than x is meaning this part, right? This part. So all is under the condition all is this part from 0 to 2 over 3. Yeah. Okay. So under this condition, what is the density function for y? So say for y is we just plug in x as 1 over 3. So 24 1 over 3 y or equal ay. So this 8y, this maybe is not density function because the total probability is not equal 1. So we need to adjust this. So we say, but anyway, like this density function is some constant coefficient. Maybe the coefficient not equal a, right? Or some constant, some coefficient multiply y. Okay. Okay. So totally, probability is y from 0 to 2 over 3. So when x equal 1 over 3, so y is that. So ky dy, so totally this. Okay, so this equal k half 2 over 3 square, right? Okay, so when y is larger than x, so y larger than x, so meaning this y is at least from 1 over 3 to 2 over 3. So this equal k half 2 over 3 square minus 1 over 3 square. Okay. So the probability, we want to find the probability equal. So totally equals us k half, and says 2 over 3 square. So here k half 2 over 3 square minus 1 over 3 square. Okay, so k times half cancel. So So this equal like a 2 over 3 square over 2 over 3 square minus 1 over 3 square. So we just multiply 9, right? So cancel this. So this become 4. This become 4 minus 1, 3. So for this problem, given that, so this is conditional. Let's say we say under this condition, we want to find the probability that these things between 1 and 3. So this is a conditional probability. So let's say that here we have two variables x and y. So we let's check what is this x, what is y, and what is this condition. Conditions initial claim is 2. So this initial claim is x or y. X, right? Initial estimate. So this probability is so under the condition initial equal 2, right? And under this condition determine the probability the final settlement is y. Yeah, final settlement amount of pay is y. So this y between 1 and 3. So the problem is just like that. X, y has this density function, and we want to find this conditional probability. So for such a problem, so again the same. Like so under this condition, we want to find a y's density function. So let's say so if y. So we just plugging x as 2. So plugging x as 2, then some constant, then y is negative 3, right? So this is a constant. Maybe it's just not just simply replace x by 2. Maybe we need to adjust this. Okay. So this y, the range is when x equal to y is just larger than 1, right? So this is when x fixed, y's range is still from 1 to infinity. Okay, so we can find this is k. So let's say this k is, we know there's a probability, a total probability from 1 to infinity. This density function dy. So this integration is alpha plus 1 negative 2, right? y2. Yeah, y negative 2. Okay, so this is just equal just negative 2 become positive 2. So this is just equal k half. The integrated out is half. So we find k equal 2. Okay. So now the problem is just so simple, right? That the function is this. We want to find the probability. So this probability is just from 1 to 3, right? K is equal to. That is so simple, right? So this one, this integrated out is y. This integrated out is y negative 2, right? Yeah, so from 1 to 3, maybe put a negative. So 1 is y, 1, yeah. So just like 1 over 1 minus 3, 2. Okay, so this probability is 1 minus 1 over 9. So we can say it's equal a over 9. So for this problem, we find the keywords giving that So what is the probability? Fusing them. So this is also conditional probability, right? So we want to find a conditional probability. Giving that, so this is giving that is this is for X or Y. 10% by the basic policy. So by basic policy, this is the percentage. Basic policy is X, right? So X is the percentage of people by basic policy. So the condition is when X equal 10%. Okay. And this is the condition. What is the probability that there's few less, so those by supplemental policy, this is Y, like Y less than 0.005. So we want to find this probability. Okay. So again, we need to find the Y's density function for Y. Let's see. Okay. So we have a joint density function. Is thus. So here X fixed. X is fixed. So that's equal to 2.1 plus Y, right? And so what is the range for, what is the region for X and Y? So let's say what is the region for X, Y? Okay. So here the company of a basic life insurance policy, and here have two policies. First one is basic, second one supplemental. So if they purchase supplemental policy, they must first purchase the basic one. So X proportion purchase by Y, the proportion for purchase supplemental. Okay. Okay. So what the condition is? I think this Y, this percentage for Y should less than percentage for X, right? We have this because those like those people buy supplemental, this percentage should be less than the percentage for buy basic, because only those people buy the basic one can buy supplemental. Yeah, so we have this condition. Yeah. Okay. Okay. So this equal, let's say it's equal. So maybe this is not a density function. So maybe we say we should put k 0.1 plus Y. And what is the condition for Y? This Y is less than 0.1 and larger than 0. Okay. Okay. So we need to find this k, right? So we need to find this k. So k equal, let's say, so Y, so total probability is 0 to 0.1. So k times 0.1 plus Y. divide equal 1, right? So equal what? Equal k. So first one is 0.1 square plus, so y, so this is half 0.1 square. So this equal 0.1 square, and here 2 over 3, right? 3 over 2. 3 over 2. Yeah. Okay. So we find k equals this. K equal 2 over 3 multiplied by 100, right? So k equals this. Okay. So now we can find the probability. So k equals this. Then, so we just need to find the probability. So p equal k 2 over 3 100. So here y is less than 0.005. So here 0.1 plus y square, plus y divide, no square, right? So by now we can just do some calculation. Let's say, so here is 0.005, right? 0.1 multiplied 0.005, yeah. Okay. Plus half 0.005 square. Okay, then simplify is calculate, yeah. So for this problem, what is question? What is expected? So we want to find the expectation. So given that, so this is conditional expectation. Okay. Okay. So let's check this condition. At first, just check this condition. So we just focus on those. Okay. So this problem, it says we have 2 life insurance policy, each with a death benefit is this, and one-time premium is this. Okay, so premium for each person is 500 sold to a couple of people, not to a husband and wife. So policy will expire at the end of 10th year. Okay, so the probability that only the wife will survive. So we just put this case the wife will survive. Only wife will survive, so husband will die. Such a probability. So we just check all these cases. Such a probability is on the wife is 0.025. Okay, and only husband will survive. So wife died, husband survived. This is 0.01. And the probability that both of them will survive. So both of them will survive is WH. This is 96. And we also have one more case that both of them died. So what is this probability? So we can add them up totally. So let's see. Both of them will die. So 0.96, 0.01, 2 5, so here 5. So this is 995, so 0 0 0 0 5. So this equals 0 0 0 5. Okay, right? Okay, so the payment the company should pay. So here pay this, right? In this case pay this, in this case we'll pay this, and here pay 0, right? Here pay, the company will pay so much 2, right? Okay. Okay. So the question is we so giving that, so we so here all condition all cases, so but we just need to check those cases. Husband survive at least 10 years. So husband survive. So we just check these 2 cases, right? Check these 2 cases. This one and this one. Okay. So we just check conditional. So we just check those 2 cases. So here this is 0 0 1 and 0 9 6. So here pay this, here pay 0, right? Okay. Okay. So we have only those 2 cases. So we say this is probability, this is pay. But so we have these 2 cases. Like here is just like we have 2 cases. Wife died, or wife don't died, right? We have only the 2 cases. But here this is not a distribution, because total probability is not equal 1. So we need adjust this. So we just changing this as there's 2 cases. Wife died. So we just check this is totally 97%. So here we can put this 1 over 97, and here 96 over 97. Okay, so okay, so this is case like this probability, and we just put the payment. Payment is this, and here's 0, right? Okay, so we can find this conditional payment. Conditional, we say, so this expectation for payment. So this payment is actually the conditional payment. So this is just equal this probability multiply this. Okay. But what we want to find, let's say, what is the expected excess of premium or claim? We want to find this. So excess of premium, expected excess of premium. So this means the premium minus claim over claim. So this is a claim. Okay. So the premium is 500. So we just check. So this, I think, so just 500. So minus this. Okay. So this answer is this, right? So for this problem, we want to determine the probability So the portion of cream is less than this. So this is just the simple probability. We want to find this probability. So let's see. So this is about for x and y. The portion of cream represent to damage to the house. So damage to the house is x and y. Oh, this is x. Yeah. Okay. So we just want to find this x is less than 0.2. Okay. So this one just find this just this simple probability. So here let's check. Okay, so the regions this region xy is xy less than 1, so this x plus y equal 1. Okay, so we know integration is this. So we want to find x less than 0.2. So this is 0.2. So we know we just want to find this the probability in this region. This part. So we know, okay, so there's a probability, so we can say easily. So determine x from 0 to 0.2. Then for y, so y from 0 to 1 minus x. Okay, then there's the function 1 minus x plus y. Okay, dy. So such a problem is easy, just the double integration. Okay. So let's do this. Okay. So 0 to 0.2. Okay. So integrated out here 1 integrated out is 1 minus x, right? And minus this x. The x is constant. So x multiply 1 minus x. And minus y. So this y integrated out is half 1 minus x squared. Okay. Yeah. Okay. So then simplify a little bit. Just do this integration. 0.2. So here 1 minus x. So here simplify a little bit. Yeah. So let's see. So 1 minus x plus x squared. So minus half of, so this is square of half. So here plus 2x plus x. So here minus the half x squared, right? Dx. Okay, so simplify a little bit. Let's see. X, this 1, and so this is half. Constant 1, 5, so x, negative x squared plus half x squared dx. Yeah. Okay, so now this integration, that's easy. Okay, so for this one, we want to find expected time at which the device fails. We want to find expectation. So when the device will fail, okay, so this is the device contains 2 circuits. So the second circuit is the backup for the first one. Okay, so when first fail, so we will use second one. So So that device will fill meanings time for x plus y, right? So here x time for first one can work. Then first one fail, we just plus this y second one, right? So total time this machine or this device will work is x plus y, right? So we need to find x plus y, okay? So we have this density function. So then such a problem just the integration, okay? So let's say the range is regions x from so y larger than x, yeah, okay. So we just took y. So suppose this is y equal x. So y larger than x is this part, right? Above part. So this integration of which can check x from 0 to infinity dx. Then y for x fixed, y equal x to infinity dy. So then here just so x plus y. Then this 6 density function is this. Okay. So this is just such double integration. So double integration problem. So let's do this. Just a double integration. Just do step by step. So integrate by y first. So here we have two parts: x 6 negative x. This is constant. So this is x 6 negative x 6 is negative x. So just negative y. So just like this, like x from infinity is negative 2y dx dy. So here x constant. So this integration equal half is negative 2x. Okay. Yeah. Okay. So just this one just like exponential distribution, right? Oh, anyway we can find that. So this is integrated out is half is negative 2x. Okay. So plus y. So for this one, let's say so plus. So x. Yeah, plus. So 6 is negative x is constant. So take it out. So becomes so here we have y is negative 2y. So this integration y is negative 2y dy. So this integration is a little bit tough. We should use integration by parts. Yeah. So this is, I think, the most difficult math problem for those exam P1. Okay. So for this one, we need double. Oh, not double. We need use integration by parts. So let's see. So this equal. We just put this log y d is negative 2y. So this is negative. So this is constant negative half, right? So like this. So this equal negative half y is negative 2y infinity x. Okay, and then so plus okay. So here is almost a headache. With such a problem, it takes some time. So we try to use a better way. So better way is use exponential distributions mean, and so we have this like if x follow exponential distribution, then expectation of x is 1 over lambda, right? So maybe we just use this result. Okay, so let's say, so here, so we just for this one we just do substitution. Let's say this is, so here x constant, yeah, y is negative 2y dy. Okay, so equal, we just let this y minus x equal t. So when y equal x, t equals 0. So 0 to infinity. So this y become x plus t. Okay, and e negative 2. So y is x plus t. Okay, so dy dt. Okay, so here x is constant. Okay, so we can take it out. This equal is negative 2x. Okay, so first one is 0 to infinity. X is negative 2t dt. Okay, so plus this 0 to infinity t e negative 2t dt, right? Okay, so for this one, the x constant, so this integration is easy. For this one, so this one is just x half. Okay, and for this one, so this one just like lambda is negative lambda t. So t, so let's say, so this is just like an expectation. So if we multiply lambda, so negative 2, then just let's say lambda t is negative, yeah. So this one integrated out is also half. Okay, so maybe use this one, yeah. Okay, so then, yeah, we plug in here, so we can find this. We can plug into here, so this one become integration about x, so we can easily to get this. Okay, so for those integration, maybe for exponential integration we use this, or one more variance for x equal 1 over lambda square. Maybe we can use those results. Okay, so for Marmite general function, for one variable Marmite general function, we have this. Okay, so this is the definition for Marmite general function. So for Marmite general function, we have this, from Marmite general function to Marmite, we have this first derivative t equals 0 just equal mu1 first moment. Second derivative is second moment. Okay. So for two variables, the moment generated function definition thus. Okay. So here we have other things, variable with variable. So typical example is like x follows some distribution with parameter lambda. So this lambda is not fixed. This lambda can change. This lambda is also follow some distribution. So lambda is also a variable. Okay. So for such a case, just if we want to find the expectations, or just we have this, so we can call this a double E. Just the condition fix this first, then just check then let this change, right? So we have this one. So for variance, so there's a formula. So we just remember there's a formula this. We just say V so under this condition plus V under this condition. So condition is just fixed. Okay. So for this problem, like x for a uniform distribution, x from a uniform distribution from 0 to theta. But this theta also can change. So what is the expectation for x? So expectation for x, we say that if theta fixed, then this is to theta over 2, right? Then we just let this theta change. So theta came from 2 to 4. So we say this expectation just 3 over 2, right? So for this problem, so let's say, suppose we want to find variance for x. So variance for x, so we should do this, like variance for x is equal VE plus EV. What does this means? Means like for this one, we just let this find expectation first. So let this parameter fixed, let this lambda fixed. So we know this expectation is so if x follow exponential distribution with the parameter lambda, so the expectation is 1 over lambda, right? Okay. And then let's see. So when lambda fixed variance for this x is 1 over lambda square. Okay. So now we just let lambda change. So lambda is from 0 to 3. So we want to find 1 over lambda's variance. Okay, find 1 over lambda's variance. And here find 1 over lambda square's expectation. So we can find them, right? Okay, so we can stop here.